Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your channel Chandan Physics. In this video, we are going to discuss plane and spherical waves, longitudinal and transverse waves. Let's begin. What is wave? A wave is a disturbance which propagates energy and momentum from one place to other without the transport of matter. There are various types of waves, but here we classify the waves as plane and spherical waves, longitudinal and transverse waves. First we discuss what is plane and spherical waves. So, spherical waves, the spherical waves are the waves in which locus of all particles of the medium vibrating in the same phase are spheres. In that of spherical waves, the source of wave is a central point, or we can say that is a point source. So, how the spherical waves is created? Let me consider a point source. Point source of light S, which sends out waves in all directions. And that medium is homogeneous and isotropic medium. Since it is isotropic, so the speed of light is same throughout that of medium. Let after time t, all the waves reach a point lying on that of particular sphere having the radius ct. At a time t, wave reach at ct, here ct, here at a distance of ct. The surface of sphere at particular instant, that is the surface of sphere at the instant of t, that represents a wave front at that particular instant, as we discussed in the earlier videos regarding the concept of wave front or spherical wave front. Thus, the spherical wave front is produced by a point source S of light, because the locus of all such points which are equidistant from that of point, these are equidistant from that point, is a sphere. In 3 dimension it is a sphere. So, spherical waves are the waves in which the locus of all particles in that of medium vibrating in the same phase are spheres, and in case of spherical waves, the source of that wave is a central point, or we can say that is a point source. Some examples of that spherical waves, some examples: spreading and propagation of waves, propagation of waves from an intense means if there is a pond, if I throw a stone to that of pond, so the waves are created, and these waves are the form of spherical waves. That's example of spherical waves. Another example of spherical wave, coherent point source of light. Coherent point source of light. And again another example, an explosion. An explosion that also generates a spherical wave. An explosion generates spherical waves. All these cases the source be a point, or we can say that is the central point through which the spherical waves are created. Then plane waves, a small part of a spherical wavefront originating from a distant source of light will appear a plane wavefront, and the corresponding waves will be the plane waves. That is a source S. So light waves are from this source. These are the spherical wavefronts. If I consider a small portion of that of spherical wavefront, that is the extended view of that of small portion, here the light propagates like this. This is a plane waves. And examples of plane waves, the ripples or surface wave are the example of plane waves. Ripples, as we see in case of ponds or any kind of water reservoir. Next, difference between longitudinal and transverse waves. Transverse waves are those waves in which particles of the medium vibrate at right angle to the direction in which the wave propagates. If that is the direction of propagation of waves, in case of transverse waves, that represents just like this. Here the particles are vibrating here the vibration of that of particles at right angle to the direction of propagation of waves. But in case of longitudinal waves are those waves in which the particles of medium vibrate along the direction of propagation of wave. If that is the direction of propagation of wave, so the particles are vibrating like this. just like that, along the direction of propagation of that of wave. Here in case of transverse waves, they can travel through vacuum, but in case of longitudinal waves, they require a medium for their propagations. Longitudinal waves require some medium for their propagations. In case of transverse wave, they travel with the velocity of light, which is equal to 3 into 10 to the power 8 meter per second, but in case of longitudinal waves, they do not travel with the velocity of light. Here the distance between two consecutive crests and troughs is called wavelength. That is the crest, that is the trough. So the distance between two consecutive crests, here is the crest, here is the crest, the distance between these two is the wavelength. Distance between two consecutive crests or distance between two consecutive troughs with the wavelength. But in case of longitudinal waves, the distance between two consecutive compressions and rarefaction is called wavelength. Compressions means if there are a number of particles vibrating, that is the compression, and here is there will the separation will large, so that is the rare one, that is the compressed one, that is the rare one. So the consecutive compressions and consecutive rarefaction is also known as the wavelength in case of longitudinal waves. They can be polarized. Here, since there will be upper half and lower half, we can polarize of a pole portion if we take either upper half, either lower half by polarizing. But in case of transverse waves, all are vibrating in that of same phase, but at that particular condition no polarization occurred. They can't be polarized in case of longitudinal waves. There is no change in density of medium during the transverse wave motion. Since all are in the same the vibration, so the density will be no such change. Here the number of particles vibrating in the upper portion is same as the number of particles vibrating in the lower portion. So density will be no change during that of wave motion, transverse wave motion. But in case of longitudinal wave motion, there will be a change in density, as we say one is compression and another one is rarefaction. So in case of compression, the change in density is higher as comparison to that of rarefaction. So there is a change in density of motion during the longitudinal waves of that of longitudinal wave motion. There are some examples of transverse waves. Transverse wave examples. Here we take the examples of transverse waves as water waves, waves in a string, and electromagnetic waves. Electromagnetic waves are some examples of transverse waves. Water waves, waves in a string, and electromagnetic waves are some examples of transverse wave. But in case of longitudinal waves, examples of longitudinal waves: sound waves and wave in a spring. Sound wave and wave in a spring are some examples of longitudinal waves, sound wave and wave in a spring, example of longitudinal waves. So, with the help of this video lecture we understand idea of waves as the classification as plane wave and spherical waves. Plane waves its examples, spherical waves its example, plane waves and its example. Difference between longitudinal and transverse waves. There are various points. Throughout we discuss the difference between transverse waves and longitudinal waves and examples of both longitudinal as well as transverse waves. So, with this useful and informative notes, let me wind up this session. Thank you.